Hello everyone. Today we are going to learn how to calculate the oxidation state or oxidation number of an element in a given compound. This concept is very important in examination point of view, and in many competitive examinations we will be asked to find out the oxidation number of a given element. Even in many interviews this basic concept is tested. Let's see how to find out the oxidation state of an element. If you consider any element in its native form, for example metals, in their native form their oxidation state is 0. Sodium when it is in metal, and zinc, metallic zinc, aluminium sheets where you will have aluminium atoms. In all these cases the oxidation state of the element is 0. Even if you consider oxygen, in atmosphere it exists as O2, and we have nitrogen gas, and in atmosphere we have ozone, O3. In all these cases the oxidation state of these elements are 0. We can have the oxidation state as either as 0 where hydrogen is present in the native form hydrogen gas, or whenever the hydrogen is bound to non-metals like oxygen, chloride and so on, the oxidation state is +1. And when hydrogen is bound to metals like lithium, beryllium, zinc, the oxidation state of hydrogen is -1. So for hydrogen, the oxidation state, possible oxidation states are 0, +1 and -1. And if you consider the first group where all the elements are metal ions, the oxidation state is +1, like lithium chloride, sodium chloride, potassium chloride. In all such compounds, the oxidation state of these elements are +1. If you consider the second group elements, the common oxidation state for these elements in compounds are +2. We all know Mg2 plus, Ca2 plus, beryllium 2 plus and so on. And if you consider p block elements, the common oxidation states for this boron group is +3, carbon group is +4, and nitrogen group is +3, and oxygen is -2, and halide group is -1. And for inert gases we know it won't form any compounds, so the oxidation number for inert gases is 0. Take some specific examples. How to calculate the oxidation state of phosphorus in PCl3 or phosphorus in PCl5. First let's take the compound PCl3. So we want to find out the oxidation state of phosphorus. So whichever element that you are going to find the oxidation state, retain the oxidation state for that element as X. And we all know halides have the common oxidation number as -1. Here how many halides we have? We have 3 halides. So plus 3 into, for each halide it is -1. And overall this molecule is neutral. So you have to write is equal to 0. So X minus 3 is equal to 0. So X is equal to +3. So oxidation state of phosphorus in PCl3 is +3. In the same way we can do for PCl5 also. We want to find out the oxidation state of phosphorus, so retain it as X. And we know for halides the oxidation number is -1. So we have 5 chlorides. So it is plus 5 into -1, and overall charge is 0 because the molecule is neutral. So you will be getting the X value as 5. So in PCl5 the oxidation state of phosphorus is +5. The oxidation state of arsenic in As2O3 and As2O5. In As2O3 we want to find out the oxidation state of arsenic, As2O3. How many arsenic atoms we have? 2. So 2 into X plus 3 into 3 oxygen we have. So 3 into, for each oxygen the oxidation state is -2. -2, and since the molecule is neutral, the overall charge will be 0. So you can find out the X value to be 6 by 2, which is +3. So in As2O3, the oxidation state of arsenic is +3. Same way you can do for As2O5. Here also we have 2 arsenic, so 2x. And how many oxygens we have? 5. So 5. And for each oxygen, the oxidation state is -2. So since the substance is neutral, you have to equate it to 0. And you will get X value as 5. So in As2O5, arsenic exists in oxidation state. Right. See the few questions which are asked in exams. This is on Maharashtra CET exams in 2025. This question has been asked, and we have been asked to calculate the oxidation state of sulfur in SO3. So sulfur oxidation number, you can keep it as X. And how many oxygens we have? 3 oxygens we have, and for each oxygen, oxidation state is -2. Since the substance is neutral, you have to equate it to 0, and you will be getting X value as +6. So the answer is +6. Same way, we can calculate the oxidation state of phosphorus in phosphate ion. We all know phosphate is PO4 3-. So you want to find out the oxidation state of phosphorus. So keep it as X. And how many oxygens we have? 4. So +4 into, and for each oxygen it is -2 is the oxidation state. And overall charge is -3. So you have to equate it to -3. It is not a neutral species. So X will be -3 + 8, that is equal to +5. So the oxidation state of phosphorus in phosphate ion is +5. The same way we can calculate the oxidation state of elements which are present in D block as well as in F block. As we all aware, for D block and F block elements, they can exist in multiple oxidation states. For example, chromium, which is a 3D element, it can exist in oxidation states ranging from +2 to +6 in complexes. Same way, manganese in complexes also can show multiple oxidation states ranging from +2 to +7. And for example, you consider iron in these two substances. In ferrous oxide, it is in +2 oxidation state, whereas in ferric oxide, the oxidation state is +3. Now let's see this in MnO2 and MnO4-. So in MnO2, how to calculate? X. And how many oxygens we have? 2. So +2, and each oxygen is having the oxidation number of -2, and overall charge is 0 because it's a neutral species. So you will be getting X value as +4 in this case. Whereas in the next case, we have manganese whose oxidation number has to be determined. And how many oxides we have? 4. So 4 into -2. So overall charge is -1. So X will become as +7. The same, we can calculate the oxidation state of chromium in Cr2O3. How many chromium ions are there? 2. So 2x. And how many oxygens are there? 3. And for each oxygen it is -2. So equate it to 0 because it is a neutral species. So you will be getting X value as +3. So oxidation state of chromium in Cr2O3 is +3. Same way in potassium dichromate also we can calculate. And here also we have 2 chromium ions, so 2x. And how many potassium ions we have? 2 potassium ions. We all know potassium ion is having the oxidation number of +1. So 2 potassium ions, so 2 into +1, and 2 chromium ions, and +7 oxygen. Oxygen it is -2, and we have to equate it to 0 because it is a neutral species. So we will be getting X value as +7. So in this way we can calculate the oxidation state of different elements in complexes. Thank you for watching. Happy learning.